So this is one of those proofs that's like a two-way street because it's an if and only if. So why don't we begin by proving the easier case? And the case would be if x is even, comma, then x to the fifth is even. So this is the easier of two paths. And so let's begin this proof here. So let x be even, okay? So x equals, 2w for some w in the integers. And so what we can do now is we can raise both sides to the power of 5. So we have x to the fifth equals 2w to the power of 5. And this gives x to the fifth equals 32w to the fifth. And we have x to the fifth equals 2 times 16w to the fifth. And so we have x to the fifth equals 2q, where q equals 16w to the fifth. And that also is an integer, right? So thus x to the fifth is even, right? X to the fifth is even. Now the backwards direction, it's going to make us think a little bit more. And what's interesting in the directions, if you read the directions, they said something about like you can use some software to expand polynomials if necessary or something like that. I think they were sort of kind of giving us a hint here. So now let's finish this problem by going the other direction. And the other direction would say this. So we're trying to show that if x to the fifth is even, comma, then x is even. And why don't we actually accomplish this? Let's do this. Let's do a proof by, you can probably anticipate what I'm going to say here. Let's do a proof by contradiction. Yes, a proof by contradiction. So why don't we do this? So why don't we let x to the fifth be even, comma, but assume that x is odd. So we're going to for sure give x to the fifth is even, but we're going to assume to the contrary that x is odd, and we're going to look for a contradiction, which would then imply that x would have to be even. So we know that what we're doing, we know that it's going to be incorrect, right? We're going to run into a contradiction. But so for now, let's assume that x is odd, okay? So since x is odd, comma, x equals 2w plus 1, where w is an integer, right? That's what x is. It's an odd number. It's an even number plus 1. It sort of makes it offset, becomes an odd number. And now we have to raise this to the power of 5. So x to the power of 5 is, 2w plus 1 to the power of 5. And imagine having to take this binomial and raise it to the power of 5 and expand it 5 times. No. We're not going to do that. What we're going to do instead is we're going to go to the internet, and we're going to go and we're going to Google polynomial expansion calculator. That's what we're going to do. And we're going to type in here 2w plus 1, and we're going to raise it to the power of 5. And you get all of this gibberish here. So why don't we actually copy that down? So this is what we get for the expansion of 2w plus 1 to the fifth. We got all of this here. And so what exactly do we have here? So this equals 2, let's just call this h plus 1, where h equals all of that there. And so what have we shown? We have shown that x to the power of 5 equals 2h plus 1. But the problem is that 2h plus 1 is an odd number. And that contradicts the statement that we made earlier when we said that x to the fifth is an even number. And here it says x to the fifth is an odd number. And hence what we have before us is a contradiction, right? Denoted by sort of arrows crashing into each other. And therefore, we can conclude that x is even. So this is how you show this if and only if proof.